See here, in this one, in solar cell, what we are doing here is like, there is a P substrate and N substrate, and there is a back cover. Here's the bottom, and here on the top there is a metallic finger electrode. What happens is when light incidents on this particular surface, then electron hole recombination will be that energy is given to the there is a wafer actually, the thickness. I'll explain about this. How much thick is N and how much thick is P, and there's a back cover. Then this is the P junction. So then what happens is a metallic finger electrode, and this is a P junction diode, and there is a resistor also. Okay, there is a resistor and the current flowing through that is IR. And here we have a graph. In that we have open circuit voltage and short circuit current. So this is ISC and this is VOC. Okay, that is open circuit voltage and short circuit current. Okay, is that clear? Is it clear? So open, I'll explain about this now. Just copy this first, then I will go ahead. So basically what is happening here, when the solar light means light which is coming from the sun, when it incidents on the surface, then what happens? The current flows through this one and the junction works. Okay, now, so here it works on the same principle. So, here it is the P wafer, the size of P, it is again a PN junction diode. Okay, it's again a PN junction diode. So when what happens when light incidents onto this one? Then the thickness of this is 300 micrometer P type, and the thickness of this N is 0.3 micrometer, very, very thin. So because of that, what happened? Diffusion process will take place. Diffusion process means electron hole recombination will take place. Is that clear? Diffusion process means electron hole recombination takes place. When electron hole recombination takes place, then what happens? Current will flow. Means a potential difference is developed. Then current will flow. Clear? So I'll just write those points now. So in this chapter, you don't have any derivations, only the circuit diagrams and few graphs will be there, and you have to just explain. That's it. That is there in this particular chapters. So here the P size wafer, okay, P silicon wafer is the thickness is 300 micrometer. Okay, and it is very thin. N silicon taken over a thin, that is N type silicon wafer is how much? It is 0.3 micrometer. Okay, it is 0.3 micrometer, and there is a diffusion process. What is diffusion meaning? What is the meaning of diffusion? What is the meaning of diffusion? Flow of particles from high concentration area to low concentration area. That is said to be a diffusion. Motion of particles from high concentration to low concentration. That is said to be diffusion. Okay. So here what happens? The metallic grid occupies only very small fraction. The metallic grid was there, no? That occupies very, very small area. Now there are three important parts of this one. So number one, three basic processes are involved here. Three basic processes are involved. What are they? Number one, it is about generation, separation, and collection. Generation. Number two, separation. Number three, collection. Okay, these are the 3 points: generation, separation, and collection. So what happens here? In the generation, electron hole pair is formed due to light. Okay. Here what will happen? Electron hole pair is formed due to what? Due to E is equal to h nu. When light incidents on that one, then what happens? Electron hole pair is formed. Number two, it is about what? Separation of electrons. So separation of electrons holes due to electric field. Here separation of electron hole pair due to electric field. Okay, there is electric field due to electric field of the depletion region. Electric field of the depletion region. Electric field of the depletion region. Third one is said to be collection. So in collection, what will happen now? So the electrons are swept from n side to p type. Here in this case, electrons will move from where? P to n. Electrons are moving from P to n. Number 3 is what? Collection. Okay. In collection, electrons reaching n type are collected by the front contact. So electrons are taken by front contact, and holes are taken by back contact. Okay. Holes are taken by back contact. Electrons are taken from front contact. Okay. These are the things happening in these three parts. Okay. Now, so here P side becomes positive and N side becomes negative. So what will happen here? So P side becomes positive and N side will become negative. P side will become positive and N side will become negative. And a photo voltage is developed. When this happens, photo voltage is developed. Photo voltage is developed. Okay. And P side is positive, N side is negative. A photo voltage is developed. So now, when a photo voltage is developed across, there is a, as we have seen in the figure, what happened if you take a like a diode like this? This is P and N. This is P. This is N. So what happened? This is a resistor. So the current is flowing from, this is RL, load resistor. The current flowing is IL. Current flowing is IL. So a photocurrent IL flows through the load. So now, so what is happening? Current, there is a, in the, if you look at the graph, so we have seen in the graph what has happened. Okay, let us go to the band gap now. The band gap is 1.8, 1.5 for ideal values. Okay, please copy this one, then we will go ahead. If you have any doubt, please ask me. Once again, see from the beginning, P silicon wafer is 300 micrometers and N silicon wafer is, N-type silicon wafer is 0.3 micrometer. Very, very thin. It's like a layer, thinner than the paper, very, very thin. Now, there's because of diffusion process, electron hole recombination will take place. 3 basic processes are involved: generation, separation, collection. Generation means electron hole pair is due to the light. Separation means separation of electron hole pair due to electric field of the depletion region. Collection is what? The electron, what happens here? One more thing, electron will move from P to N. Here, electron is collected at the front contact and holes are connected at the back contact. And when P becomes positive, N becomes negative, a photo voltage is developed like this, and current starts flowing. P is positive, N is negative. So what will happen? It acts like a small cell and current flows. That is said to be IL, not I1, that is IL. Okay. This current is known as load current. Okay. And RL is the load resistor. Clear? Clear with you all?
Yes, sir.
Please copy this. Now here, for band gap close to 1.5. Band gap means energy gap. If it is 1.5 electron volt. Okay, or ideal material for fabrication. Okay, solar cells are made up of semiconductors. For silicon, the energy gap is how much? 1.1 electron volt. For gallium arsenic, that is energy gap is 1.43 electron volt. And next is cadmium telluride. The value is energy gap is 1.45 electron volt. Copper indium selenide, the value is energy gap is 1.04. Except electron volt. Okay, 1.04 electron volt. These are the values. Okay, and so the important criteria for selection. Okay, the selection criteria. What is the selection criteria of the material. What is the selection criteria of the material? Number one, it is band gap from 1 to 1.8. Number one, band gap from 1.8 to 1.8 electron volt. Okay. Number two, high optical absorption. High optical absorption. How much it is? 10 to the power of 4 per centimeter. 10 to the power of 4 per centimeter. Number three, electrical conductivity. You should have a good electrical conductivity. Number four, availability of raw material. Availability of raw material. And number five, it is cost. Okay, the cost. And what are the uses? They are used in satellites to convert solar energy into electrical energy, in calculators. Okay, in calculators also we use this solar cell. You can see this calculator. If you see this carefully, there is a solar cell here. This one. Okay, this one is a solar cell. Okay, so it's converting solar energy into electrical energy. Okay. So once again, band gap is 1.5 and silicon value, silicon, gallium arsenide, cadmium telluride, and then copper, indium selenide. All these values are given. Selection criteria, the band gap is from 1 to 1.8. High optical absorption, electrical conductivity, availability of raw material, and cost. Okay, what are the uses? Satellite and calculators. This is the place where we use this. Okay, is it clear, all of you?